In these next three videos, we'll discuss the concept of control voltage modular synthesis. We'll use a plugin named Reaktor Blocks Bass by Native Instruments to facilitate this conversation. This is a free plugin. It is a digital emulation of an analog modular synthesizer. A bit of background before we begin. Robert Moog and Don Buchla simultaneously pioneered control voltage modular synthesis, but fascinatingly, they did this independent of one another. Mr. Buchla was based in San Francisco, and Mr. Moog was based in New York at the time, although he later relocated to Asheville, North Carolina, where the Moog factory is today. I know this isn't maybe necessary to the tutorial, but I think it's important to know who came up with these ideas. Anyways, let's get started. Go to Native Instruments and add Reaktor 6 to a new MIDI track. Please do not add Reaktor 6 MFX. That's not going to work for what we're doing. Once you add Reaktor 6, click the middle rectangle underneath where it says Patch. Analog modular synthesizers commonly look a lot like what you see on screen now. At least this is how they look before someone starts plugging in patch cables to create unique synth sounds. Let's see how it looks after someone has used a bunch of patch cables in Reaktor. Now let's see what an actual analog modular synthesizer looks like. It's important to remember the name of the instrument we're discussing, modular synthesizer. You see, each little rectangle contains a module that gives the user control over a particular aspect of a sound. So now that we understand what we're looking at, let's continue forward. I'm going to delete the modules that I'm not going to use. So I'll get rid of the level for the stereo out, and I'll also get rid of the utility clock. These are incredibly useful modules, but I don't need them for the very basic synthesizer I'm going to make. Now I'll make sure that my track is armed, which is indicated by the red box in the corner here. When I push down on my MIDI keyboard, you'll notice that the box next to the words Note In gets bigger. Next, I'll add a module. I'm going to add from my bento box folder. In particular, I'm going to add a bento oscillator. This is just a very simple oscillator. That's all I'm adding here. The next thing I need to do is connect the pitch outlet from note in to the pitch inlet of my oscillator. The natural question that follows from all of this is, what should I do to get sound? Well, I could just connect the outlet of my bento oscillator to audio out, but then I wouldn't have any control over the volume. So I'm going to add a VCA, which stands for Voltage Controlled Amplifier. This will amplify the sound. Now I'll connect from the outlet of my oscillator to the inlet of my amplifier. So now the way things are set up, if I press a note on my keyboard, it will change the pitch of the oscillator. And if I click and drag up on the knob for the amplifier, it'll turn up the volume of my oscillator. Let's take a listen. We now arrive at a problem. How do we make it so that when we stop pressing a note, it stops making sound? That's where we need an amplitude envelope. So we're going to add an ADSR component for that. And remember that ADSR stands for attack, decay, sustain, release. These are stages of a basic amplitude envelope. Now I'm going to come out of my gate from note in and into the gate of my ADSR. The simplest explanation for a gate is this: it's something that opens and closes. In the case of a MIDI keyboard, when I press a key down, the gate is open. When I lift up on the key, the gate is closed. By connecting the gate of my note in to the gate of my ADSR, I'm making it so that when I press my keyboard note down, it triggers the attack, decay, and sustain. Then, when I lift up on the key, the release is triggered. The next cable connection I need to make is from the out of my ADSR to the A inlet of my VCA. I need to make sure I click on this A button you see right here. And then I need to make sure I click and drag up in the little bubble that has popped up next to my knob. So now what's happening is each time I press down my key, the attack, decay, and sustain of my amplitude envelope gets triggered, and that makes the knob go up. Each time I let go of the key, the release of the amplitude envelope gets triggered, and that makes the knob go down. This is an example of control voltage. In fact, the name of the amplifier in this particular plugin is a voltage controlled amplifier. And what that means is the voltage from the ADSR module can be used to control the knob of the voltage controlled amplifier. To put it a little bit more simply, control voltage is the use of voltage to control an aspect or multiple aspects of a synthesizer's sound. In this case, we're using it to control amplitude. Now, if I want a different waveform for my oscillator, what I can do is I can click and drag up on that little sine wave icon that you see. Watch. Now what I'm going to do is clean up this patch a little bit by clicking and dragging different modules around. And I'm also going to color code my cables by right clicking on them and selecting the colors that I want. Finally, a step that so many people forget: I'm going to save my synthesizer patch so that I can use it not only in this session, but in others as well.